Hello, my name is Mr. Farkas, and I'm going to show you my logo. I created the RFK Bobcats logo. Um, as you can see, I used the equations from Desmos. From 1, the numbers are up here in the top left, all the way to 67 equations that I used for this. So I'm going to take you through some of the different types of the equations and show you how I knew to use those equations in order to create this logo. So the first thing that I did was I looked for any vertical or horizontal lines. So as you can see, there's a vertical line right here. So I use the equation x equals 0.35 because whenever you have a vertical line, the equation is x equals something. So as you can see, if I make this x equals 1.35, that moves it over here to 1.35 on the x. And then what I did was I restricted the domain or the range. If I press Command X, you can see that this line actually continues on forever. But in order to restrict it, I had to think, what part of this line do I actually want to use? And so I looked at my sketch and I saw, where does this actually line up? And I decided to put from negative 3.6 on the y-axis right here, all the way up to negative 2.07. I used some more linear equations, vertical lines for the k, and then there's a horizontal line for the f, another vertical line, and then I tried to identify what are some good shapes of functions to fill in the rest of the letters that I had started. So here you can see that it's decreasing and then curves off right here. I thought that this kind of looked like a rational function, like one part of the rational function. Here, if I take away the restriction on the y, or the range, you can see that it's just this part of the rational function, or reciprocal function, as we've called it. And if I press Command Z, you can see that I restricted the range so that it only goes from this point to this point, because that's the only points that I needed in order to complete this part of the f. Here's another one, another rational function. And then I used a series of quadratic equations. Now, if you look at it, it's actually the same quadratic equation that I used 1, 2, 3, 4 times. I'm just using different parts of it. So if you look, if I take away one of the, if I take away the domain right here, where 2.4 is greater than x is greater than 1.99, if I take that away, you can see that the bottom of the r and the bottom of the k, all 4 of those come from the same parabola. So what I did was I just used different parts of that parabola so that I didn't keep having to find new equations. For 1, 2, 3, 4, I'm using the same equation, just different parts of that parabola. Here's another quadratic equation because the x is being squared. And as you can see, this is also a part of a parabola right here. Here's a linear equation because the x is just by itself, all it has is a coefficient. So if I take this away, you can see that it's really just a piece of a line. And if I put the restriction on the range back, then it only uses the part that I want. These functions right here are rational functions. And I know that because the x is inside of the square root, or the radical. So if you see when I take away the restriction on the domain, you can see that this looks like the square root curve on our function, on our sheet that shows us the parent functions. And when the x is positive, it goes upwards like this. And then for this one, it's just kind of like the inverse. I'm going to put on the other side. So it's a reflection actually over the y-axis. So I have some more radical functions or square root functions. And here are some absolute value functions. So here you can see that I use this absolute value function in order to make this top part of the RFK logo. And this is just something I added because I thought that it added a good aesthetic or a good look. And these are some more quadratic equations. And if you'll notice, the only different thing about these quadratic equations that I used here, for example, for this one, notice that it's x equals and the y is being squared. That was something that we hadn't learned in class, but when I was trying to figure out how to make the parabola change from positive orientation or negative orientation to going left and right, I realized if you switch the x and the y, then it actually flips it to the right or towards the left. So what I did was I just took this little piece of it by restricting the range, because here I have a maximum for the y and a minimum for the y value. So that was how I used these equations in order to create this logo. I hope that you now understand how I modified these different parameters in order to get things to move how they did, and how I restricted the domain and the range in order to just use the pieces that I needed to recreate my logo. In terms of what I learned a lot of different things in terms of how you can change the A, the H, and the K in order to transform these different types of parent functions. But one thing that I'm still struggling with a little bit is getting things exact. And when I say getting things exact, I mean if you really zoom in far, let's look at where this K meets down here. If you really zoom in, you can see that there are some corners that don't really meet exactly. So I need to change certain things in order to restrict it a little bit further. So maybe it shouldn't really be stopping at 2. Maybe it should be stopping at more like 1.99 or 1.994, because then you can see that it's actually a little bit more accurate right here. So that's something that I need to work on still, but at a certain point, you just have to decide that it's ready to go. All right, well, thank you so much. I hope you enjoyed my video. Please grade it on the rubric and let me know what I improved upon.